In this video, I'd like to show you guys how to do the experimental design experiment worksheet or lab or whatever it is. So here's your course, and the easiest way I think to get to that assignment is to click one of these buttons, and it's in this Oceanography Science module. So I'm going to go here, and here's our experimental design assignment. So I'm gonna you can see there's helpful hints right here in case you need them, and there's helpful hints for other assignments as well, but we're gonna focus on this one. So I'm gonna go ahead and I'm gonna download it, and then I'm gonna open it up. Okay, so now that I've got it up, I'm gonna go ahead and I'm gonna try kind of the internet, and I can also see the lab. I'm not sure if you can see this, so I'm going to make it a little bigger. Okay, so here it is, a little bigger. So for this, we want a definition of something, right? So to do that, I'm going to go to my course, and I'm going to click on content, and I'm going to choose Oceanography as Science, and I'm going to click on that. Okay, so here you can see this module has some definitions of our key terms and things like that. So you'll be able to see those definitions right there. Okay, so that's where you'll go to do this. So I'm gonna just I'm gonna type in here, and I'm gonna say oceanography, and that's where you'll find those definitions. Okay. So now it wants you to design a controlled experiment to test the hypothesis if the amount of salt added to the water will change the density of the water. Okay, so the way you would write your hypothesis is your hypothesis would actually be if the amount of salt changes, the density of the water, then the density of the water will change. Okay, so you can write it like this. If you're really good at statistics, you can write a null hypothesis and alternative hypothesis. So the null is always if the amount of salt changes, there will be no change in density. And then your alternative would be if the amount of salt changes, then the density of the water will change. But in order to use a null and an alternative hypothesis, you must have statistics. Okay, so I'm going to write here HO and HA require statistics. Okay, so if you're not going to run statistics on your data, then don't use those. Okay, so here we're just gonna design the experiment. So we're gonna list the steps we want to perform the experiment, and if you look here, here's the definitions for your variables as well. But if you scroll down a little bit, there's some other information for you guys, and it shows procedures have details. Okay, so great procedures are detailed. They're detailed enough that someone else can perform that experiment. Okay, so if you want to make an experiment, you want yours to have more detail like this than this. Okay, you want to make sure that it makes sense. Okay, so I'm not going to write your steps for you, but I'm going to kind of put some hints as some things that you guys should maybe do when you're writing your experiment or coming up with your steps. So you'll want to identify the independent and dependent variables. Okay, the independent is going to be the thing that you're changing. Okay, So in this experiment, it's going to be amount of salt. And your dependent depends on that independent. So that's the thing you're measuring. So if you look at this experiment, the thing that you're measuring is going to be the density of the water. Okay, so you want to make sure you have that. So for this is a controlled experiment, so it's not going to be an in situ experiment. It's not going to be an observational experiment. Okay, so you're going to want to have at least 3 experimental plots or experimental groups and 1 control. Okay, because you're about salt water and the density for your control, you're going to use fresh water. Water with no salt. Okay, and then you could do different parts per million or whatever. So you could do parts per thousand, parts per million. You could do 10, 20, 30, whatever it is. Okay, these are examples. Okay, so you'd have at least these 3, and then you'd have your controls. So you'd have 4 groups. Now, if you really want to do a really good experiment, you would have at least 3 of each of these. Okay, so you would have 3 containers of 10 parts per thousand, 3 containers of 20 parts per thousand, and 3 containers of 30. And if you wanted, you could also have 3 containers of control, and that would make sure that you're, if something happens to one of your controls, you've got a backup, which is another good thing about having replicates, right? That's what we call these each additional one, we call them replicates. Okay, because if something happens, let's say you knock over the 10 part per thousand cup that and you only have one of them, and you knock that one over, you no longer have 10 parts per thousand as part of your experiment anymore, right? So in order to kind of correct for that, or make sure that that doesn't happen, you have 3 replicates, and that way if you knock one over, you still have the other 2 left, so you're not like completely out of luck. Okay, and it's happened before to me when I've done experiments in the lab where something happened. I'm running a sample. One time I was measuring the amount of chlorophyll in coral tissue, and I did a whole section, and I just completely screwed them up. I put like the wrong amount of acid in there, which made all my readings come out really wonky. And so because I had replicates, it was okay. I could go back and look at the others. But if I didn't have any replicates, that would be that, right? I'd be out of luck. Okay. You want to discuss how often you're going to measure or take data. Okay, for this one, you only need to take data once, right? But for a different experiment, you might have to take data, every day. You'll say every day at 3 p.m., every day at 5. That's just an example. You also want to discuss everything that you're going to try and keep the same. Okay, so for this experiment, the amount of water, so you might want, I don't know, like 2 cups of water, or cups isn't very good. Let's do like maybe 50 mils. But you'd want every single experimental group to have the same amount of water. You want to have the same amount of sunlight exposure. Now, that doesn't really make a lot of sense in this experiment because you're just going to make up these 3 groups and then measure the density, right? But, for an experiment that would go over time, you would want to make sure your sunlight exposure was the same, the temperature was the same. That might be important for this one, the temperature of the same. You know, if you're doing an experiment with animals, you'd want the same of subjects in each for example, my AP students do a lab. Well, they kind of look at the data from the lab, but each experimental group has 10 brine shrimp. So you'd want to make sure, you know, you have, for this one, you would have 3 containers of brine shrimp, and you'd have 10 brine shrimp in each one. So you'd have 30 brine shrimp total being exposed to 10 parts per thousand. Or, you know, the same thing for the 20 parts per thousand. You would want, you know, 10 brine shrimp in each one of these replicates. Okay. So you just want to keep as much the same as possible. If it's plants and you're going to water the plants, you want to give them the same amount of water. Unless your experiment is determining, you know, different amounts of water, how a plant grows relative to different amounts of water. But if it's not, then you want to make sure they get the same amount of water each day. So those are the kind of things you want to keep the same. Okay. And then you want to discuss, for this one especially, how you're going to measure the density. Okay, now the density formula is density is mass divided by volume. Okay, so for this one, you could take the mass of each experimental group and divide it by the volume. Okay, and the volume you should know, because you would want each of these to have the amount of water, right? You'd have the same amount of water, 50 mils, whatever it is. Okay, so those are things you're going to keep in mind when you're making your procedure. Okay, and then you want to discuss what materials you're going to use to carry out this experiment. So what did we talk about? We were going to have experimental and control group cups. You'd want to have something to measure that volume. Right? You're going to need something to measure the mass. Now you're going to actually, when you do this, you're going to say, I'm going to use a beaker or I'm going to use a scale. So I'm just discussing things you're going to want to include, but you're going to need to be a little more specific than something to measure volume. You're going to actually want to put whatever you're using to measure volume. Okay. Things that you don't have to write. You don't need to include paper, data table, pencil, stuff like that. You kind of expect that the person that's doing the experiment knows that they need paper, data table, pencil, etc. Okay. For your materials, you're going to discuss how to make, you'll say like solutions of 10 part per thousand, 20 part per thousand, and 30 part per thousand salt water. Okay. Now you don't have to do this. You'll write the solutions, and then here you'd want to describe how to make your solutions. Okay, so you're going to want to, you want to be specific enough that the person, they'll describe how to do it. And you'll want to do these things in order. I'm just kind of doing it as I think about it. Okay, and then you want to identify your variables, right? Which is what we've discussed up here, right? We have our independent and our dependent, and then all the conditions we want to keep the same are controls, right? We discussed those. So you'll describe the ones that are relevant to this experiment, right? Not everything I've discussed. Okay. Okay, so that's how you do part 3. Part 2. And now this part is saying another student did a study comparing the temperature of water and water density. Look at the following data and answer the question. Okay? So you want to discuss the independent variable. Remember, the independent variable is the thing that you changed, right? The thing that the student changed. Okay, so did they change the temperature and then measure the density? Or did they change the density and then measure the temperature? Okay, which one of those makes more sense, right? Okay, so for this one, you want the thing that changed in response to the independent variable. Okay, so the independent variable is the thing that the student changed, and then the dependent variable is the thing that changed in response to whatever that student changed. Okay. Now, do we know this is a controlled experiment? Well, the student changed something, right? The student set up different groups, and they changed the temperature, right? They changed the temperature and then they measured the density. I'm going to go ahead and give it to you. That's what they did. So if you watch this video, you got the answers to 4 and 5. So it is a controlled experiment, right? Because they changed the temperature. An experiment that is not controlled would be like, going out in the wild and counting how many ants you find in a certain area. That would not be a controlled experiment because you didn't set that up. You just went there. Okay, so now we're going to make a line graph of the data, and I'm going to show you how to make that line graph in Excel. Okay, so hold on a second, and I'm going to open Excel. Okay, so now I have Excel open, but I also have my lab open, and I've just got it set up right here so I can see both. And here's what I'm going to do. I'm going to take this data table, and I'm just going to copy it, and I'm going to paste it into Excel. Okay, so now I'm going to make my line graph. Okay. Okay, so let's make this graph. I'm just going to highlight this. I don't like highlighting the titles. We can always add that later. So I'm going to go here to the charts, and I'm going to make one like this. Okay, and then we can click this plus. We can add titles. Remember, you need to have your you need to put your units on here too. So I'm going to put grams per cm3. And for here, I'm going to put degrees Celsius. For our title, we can do temperature versus salinity, or density, sorry. You can change your colors if you want. Let's discuss how to make a best fit line just in case you might need it later. So that's a best fit line that we could add if you wanted to. You don't have to, but there's our graph. Okay, and then to put your graph in your lab, you can just take this right here and you can copy it, and then you can paste it, and it'll paste it right in. Okay, and then you want to discuss what can the student conclude about temperature. Okay. Does temperature affect the density at all? Okay, so you would discuss here. Okay, you will write okay, so you'll write something there. Okay, then once you have everything you need, you can go ahead and submit to the Dropbox folder. Make sure you put your name here on here somewhere. So if this was mine, I would write my name right here. Okay, that just so I want to make sure I did some work on this, right? It wasn't the most difficult thing I've ever done, but it wasn't exactly the easiest either. So I want to write my name on it because I want to make sure the teacher gives me credit for my lab, right? And then that's how you do it, and you'll just turn it into the Dropbox folder. So hopefully this video is helpful.